There's a telescope out there that most people haven't heard of, and it's already changing everything we thought we knew about the universe. Not with a single dramatic discovery, but with images so vast, so detailed, and so unsettling that scientists are openly admitting they weren't ready for what they're seeing. The Euclid Space Telescope has released its first light images, and they don't just show pretty galaxies, they reveal structures we barely understand, patterns shaped by invisible forces, and a cosmos that looks far more complex than anyone expected. Once you understand what you're actually looking at, some of it is genuinely difficult to sit with. Euclid is not your typical space telescope. It wasn't built to zoom in on one beautiful nebula or study a single star system up close. Its mission is something far more ambitious and far stranger. Launched by the European Space Agency in July 2023, it now sits 1.5 million kilometers from Earth at a gravitational sweet spot called Lagrange 2. From there, it has an ultra-wide field of view, capable of capturing enormous stretches of sky in a single shot while still holding razor-sharp detail. It can see individual galaxies clearly, while simultaneously showing how millions of them connect into vast cosmic networks. But here's where it gets strange. Euclid isn't just mapping light. It's mapping the influence of something invisible, using a phenomenon called gravitational lensing, the subtle bending and warping of light caused by massive objects. Euclid is tracing the skeleton of the universe, a skeleton built from something we cannot see and do not fully understand: dark matter. And what it's finding is deeply unsettling. When Euclid sent back its first mosaic of the southern sky, scientists were stunned. In a short observing window, the telescope captured 260 separate images, covering an area of sky 500 times larger than a full moon. Stitched together, they revealed millions of stars and galaxies in extraordinary clarity. And that image, as overwhelming as it is, represents roughly 1% of the final map Euclid is expected to complete. 1%. That realization alone is enough to make you pause. Researchers can zoom from the largest cosmic structures all the way down to individual galaxies without losing focus, watching how matter organizes itself across incomprehensible distances. This is not just a photograph. It's a preview of the largest, most detailed three-dimensional map of the universe humanity has ever attempted, and it immediately raises uncomfortable questions about how little we've truly explored. What they found next, nobody expected. One of the most striking early images came from the Perseus cluster, a massive gathering of galaxies sitting about 240 million light-years away. In a single frame, Euclid captured over 1,000 known galaxies, plus more than 100,000 distant background galaxies behind them. But when scientists looked closer, they found something they hadn't anticipated: more than 630 previously unknown dwarf galaxies hidden within the cluster. Objects so faint they had slipped past every telescope before this one. This matters for a specific reason. Dwarf galaxies are extraordinarily sensitive to the gravitational pull of dark matter. Their shapes, positions, and subtle distortions act like tracers, pointing to where dark matter is concentrated. The fact that so many of these galaxies were completely invisible until now suggests that dark matter's grip on the universe may be far more intricate, far more pervasive than we previously believed. The universe doesn't just contain dark matter. It appears to be built around it. Euclid is also rewriting our understanding at smaller scales. In a nearby irregular galaxy called NGC 6822, it uncovered ancient low-metallicity stars that mirror conditions from the universe's early years, a window into how galaxies looked and behaved billions of years ago. In a globular cluster called NGC 6397, it resolved faint stars in the outer regions that were previously drowned out by brighter neighbors, unlocking new clues about the Milky Way's own history. And in the famous Horsehead Nebula, its sensitivity revealed evidence of free-floating planets, Jupiter-sized objects drifting through space without any star to orbit. Rogue planets, it seems, may be far more common than anyone imagined. But here's the part that changes how you see everything else. As scientists began assembling more of Euclid's data, a pattern became impossible to overlook. Galaxies are not scattered randomly across space. They are arranged along enormous filaments, vast cosmic threads stretching across hundreds of millions of light-years, intersecting at dense nodes where galaxy clusters pile up. Euclid makes this structure painfully visible. It looks less like a peaceful universe and more like a gigantic neural network, with matter flowing along invisible pathways shaped almost entirely by dark matter. These filaments aren't theoretical anymore. You can see their influence in the way galaxies bend, stretch, and align along them. And the terrifying part isn't that they exist, it's their scale. This cosmic web dominates everything. Every galaxy, every cluster, every void, all of it is embedded within this structure, guided by forces we still cannot touch or detect directly. Euclid's ability to map gravitational lensing across millions of galaxies adds another layer of unease. Massive concentrations of dark matter warp space itself, bending the light of everything behind them. These distortions are subtle, nearly imperceptible without Euclid's resolution, but when mapped at this scale, the picture becomes clear and deeply uncomfortable. The dominant form of matter in the universe is completely invisible. It doesn't emit light, it doesn't reflect it, yet it outweighs everything we can see, and it silently controls the motion and fate of entire galaxies. We are not the majority, we are the afterthought. Euclid also reaches back through time in a way no telescope has managed before. Some of the galaxies in its images are more than 10 billion light-years away, meaning their light left on its journey when the universe was still young. By capturing these ancient galaxies alongside much closer ones in the same frame, Euclid lets scientists compare the cosmos across most of its history in a single observation. What they're seeing is that large-scale structure formed earlier and more efficiently than expected. Galaxies clustered faster. Dark matter organized itself sooner. The universe may have grown up far more quickly than our models predicted, and that forces a serious re-evaluation of how cosmic evolution actually works and whether our current understanding of gravity itself is complete. And that's when everything starts to feel truly vertiginous, because all of this comes from 1% of Euclid's planned survey. 99% of its map is still missing. Over the next 5.5 years, Euclid will continue scanning the sky, filling in gaps, sharpening structures, and uncovering patterns we don't yet know how to look for. If this is what the universe looks like at 1% resolution, the full picture may be genuinely overwhelming. Euclid isn't just collecting images, it's building a data set so large and so detailed that it may force fundamental changes in cosmology, from the nature of dark matter and dark energy to the very laws governing the expansion of the universe. One of Euclid's more quietly disturbing findings is what it reveals about the empty spaces between galaxies. Vast cosmic voids stretch across hundreds of millions of light-years, and at first glance they appear almost completely barren. But Euclid shows they aren't truly empty. They are shaped, bordered, and defined by the same invisible forces building galaxy clusters. The way galaxies cluster around the edges of these voids suggests that dark energy, the mysterious force thought to be driving the accelerating expansion of space, may be actively pushing matter outward. These voids feel less like gaps and more like pressure zones, regions where the universe is being stretched apart from within. The large-scale structure of the cosmos is not just passively expanding. It is being actively rearranged. Euclid was specifically designed to hunt for dark energy, to track how the expansion rate of the universe has changed over billions of years by measuring the positions and distances of billions of galaxies. Early analysis of its first data already hints at subtle deviations from expected models. These deviations are small, but they are persistent. They suggest that dark energy may not be a fixed constant, as long assumed, but something that evolves over time. If confirmed, this would fundamentally alter our understanding of cosmic history. The force shaping the ultimate fate of everything may be more dynamic, more complex, and far less predictable than we ever imagined. What they found next, nobody had a framework for. As Euclid's datasets grow, scientists are confronting a new kind of challenge that has nothing to do with telescopes or physics. The sheer volume of data is overwhelming human comprehension. We're no longer talking about thousands or millions of objects. We're talking about billions of galaxies mapped in 3 dimensions across cosmic time. Patterns that define the universe are too large and too intricate to grasp without advanced algorithms and artificial intelligence. In a strange way, Euclid is forcing us to rely on machines to understand what machines have observed, a feedback loop where our knowledge of reality increasingly depends on systems interpreting data beyond direct human intuition. The unsettling part isn't the data itself. It's how much of the universe may exist beyond what our minds can naturally comprehend. This points toward a deeper, more uncomfortable implication. Dark matter, dark energy, gravitational lensing, accelerated expansion. Together, these phenomena dominate the universe. Yet they are explained by theories full of gaps, placeholders, and open questions. Euclid's precision exposes just how much of our cosmic model rests on things we don't actually understand. We can map the effects with extraordinary accuracy. We still don't know what's causing them. Euclid is not just revealing the universe, it is revealing the limits of our own understanding, showing us a cosmos where most of what matters is invisible, unexplained, and known only through its influence on everything else. There's something philosophically disorienting about Euclid's images when you sit with them long enough. At first they are breathtaking. Galaxies glow, nebulae swirl, star clusters sparkle with an almost artistic elegance. But the longer you look, the more unsettling they become. That beauty is not comfort. It is precision. Every sharp edge, every perfectly traced filament, every delicate distortion is evidence of forces acting relentlessly across unimaginable distances. The universe in these images is obeying rules with brutal, indifferent consistency. Gravity never rests. Dark matter never loosens its grip, expansion never slows. What looks visually serene is, in reality, the signature of a cosmos constantly pulling, bending, and stretching everything inside it. Euclid's data also reinforces a deeply unsettling hierarchy. Galaxies are not the architects of cosmic structure. They are the decoration. Dark matter halos form first, collapsing under gravity long before a single star ignites. Galaxies come later, forming inside these pre-shaped halos, lighting up regions that were already defined by something invisible. Everything we can see, every galaxy, every star, every planet, is riding on a hidden framework that decided long ago where things were allowed to exist. The visible universe is secondary, almost superficial. The real structure was already in place before light itself had much to say about it. One of the most mind-bending capabilities Euclid possesses is its ability to compress cosmic time into a single frame. In one image, nearby galaxies appear as they are today. Distant galaxies appear as they were billions of years ago, and faint structures near the edge of the observable universe appear as they were shortly after everything began. Past and present coexist in the same photograph. Scientists can track how galaxy shapes change, how clustering evolves, how dark matter's influence intensifies, all by comparing objects at different distances in the same field of view. The terrifying realization is that what we call now is just a thin slice of a much larger process, one that began long before Earth existed and will continue long after it's gone. As Euclid's early data continues to be analyzed, a pattern is emerging that every scientist recognizes, but none of them welcome. The questions are growing faster than the answers. Each new structure mapped introduces anomalies. Each new lensing signal raises doubts about our model of gravity. Each refined measurement of expansion nudges dark energy models further toward uncertainty. Euclid is not just filling gaps in our knowledge, it is exposing how provisional, how fragile that knowledge really is, and the truly unsettling part isn't that we don't have answers yet. It's that the universe Euclid is revealing may require questions we don't yet know how to ask. Step back from all of this, and one thing becomes impossible to deny. These images are not disturbing because they show destruction or chaos. They are disturbing because they show order, precise, structured, deeply interconnected order, governed by forces we cannot see, cannot touch, and still cannot explain. Dark matter is not a background detail. It is the main architect. Dark. Energy is not a footnote in a physics textbook. It is actively pulling the universe apart, and gravity, as we understand it, may not be telling the full story. Euclid is forcing us to confront a truth that is both humbling and deeply strange. Most of the universe is invisible. Most of what matters operates entirely beyond our direct perception. Galaxies follow paths they did not choose, shaped by forces older than stars. Even empty space is sculpted by something we have no name for beyond a placeholder. And this same cosmic machinery shaped our galaxy, our solar system, and ultimately, every atom in our bodies. We are not standing on solid ground in a calm and stable universe. We are riding inside a vast, dynamic structure built on physics we are only beginning to glimpse, moving through space according to rules we haven't fully written yet. Euclid's images are beautiful, yes, but they are also honest. They show a universe that does not revolve around what we can see, what we can easily measure, or what makes us comfortable. And this is only the beginning. 99% of its map is still waiting to be revealed. If the first 1% is already challenging our understanding of dark matter, dark energy, gravity, and cosmic evolution, imagine what the full picture will force us to rethink. The universe Euclid is revealing isn't new. It's been there. All along, we're just finally seeing it for what it really is.